Good morning everyone. Today in this lecture, we will try to understand Boolean instruction set of 8051. So in the very last lecture, we have gone through the various logical operations what are being done in 8051. In this lecture, our focus will be to make you understand about Boolean instructions of 8051 and the related operations. So these are the objectives where we will be studying various Boolean instructions of 8051. We will try to understand their various formats in which they can be written. We will also try to frame some example instructions so that how to utilize the given instruction, that will be clear in your mind. Beginning with the introduction part, when I talk about Boolean instructions of 8051, basically in Boolean operation, we are more concerned about individual bit level operation, right? So in entire 8051, you can do two types of operation. One is byte level operation and the second one is bit level operation. So byte level operation is something which handles 8-bit data at a time, and bit level operations are those which handle only individual bits at a time. So Boolean instructions are mainly for performing bit level operations. So here you can see that this group of instruction is associated with single bit operations of 8051, as I have already stated that this group of instruction allows individual bits of bit addressable registers. Now you might be knowing that 8051 has got many bit addressable registers and bit addressable area of memory location also, right? So there are many bit addressable registers. PSW, if you talk about, that is flag register of 8051, that is also bit addressable. So bit addressable registers and the bit addressable memory locations, even carry flag, that is also single bit flag, that can be manipulated. Keep in mind, when we are talking about the flag register, only carry flag can be operated using bit level operation, and the remaining single bit flags, that is parity, overflow and auxiliary carry flags, are totally unaffected, unaltered. So let us see what type of operations you can do in this Boolean instruction of 8051. You can set the single bit, you can clear the single bit, you can complement a single bit, and you can go for conditional jumping on some condition. So let us see the instructions one by one. As I told you, CLR is clear. So whenever you want any single bit to be set as 0, you can write CLR, the bit number. So let us say if I write CLR P1.1, P1.1 is the bit that I want to reset. So when I execute CLR P1.1, the pin P1.1 port number pin goes to 0. Similar to that, if I write CLRC, where C stands for carry flag is reset to 0. When you want to set the bits, the instruction is set B. B stands for bit, which bit you want to set. So let's say when I write set B A.2. So what I want to do here is accumulators D2 bit, I want to set it to 1, right? So I write simply set B A.2. See, accumulator is bit addressable register. That is how we are able to write it as A.2. Then next to that, if you want to set carry flag, you can write set B C. Again, C stands for carry flag. So with that, carry flag will be posed to 1. Similar to that, you have complement instruction, complement single bit. So when I write CPL 40 hex, this 40 hex is nothing but single bit address of memory location. Okay, so 40 hex is the bit addressable memory location which is holding either 0 or 1. So when I write CPL 40, if 40 hex location is carrying 0 bit, it will be inverted to 1. If it is containing 1, then it will be inverted to 0. Similar to that, you can do ORL, that is ORing operation, and ending operation on a single bit. For an example, if you write ORL C comma 20 hex, right? So C is the carry flag, which is holding either 0 or 1, and 20 hex is the bit addressable memory location, which might be holding 0 or 1 again. So when I write ORL C comma 20 hex, the status of carry, which might be 0 or 1, and the content of 20 hex bit addressable location, which might be either 0 or 1, will be odd. Similar to that, you can write ANL C comma slash 34 hex. That is 30. When I write slash 34 hex, if 34 hex is holding 0, then it will be complemented to 1. And if it is holding 1, then the location content will be holding now 0. So ANL is for ending operation on a single bit. Keep in mind, we are performing this operation on single bit source and destination operands. Next to that, we have move. So very simply, if you recall, move was the instruction that was allowing you to transfer 8-bit content of source register into 8-bit content of destination register, right? So here, what difference it is going to make when it is move based on Boolean operation? Move, when I consider on Boolean operation, move is handling only single bit data transfer from source to destination. So when I write move C comma 3fx, 3fx is the single bit memory location, which might be holding 0 or 1. So that 0 or 1 content of this memory location goes to carry flag. Next to that, you have several jump instructions which are based on single bit status. When you write JC, JNC, what does it mean? Jump. J stands for jump, C stands for carry. So JC means jump if carry flag is set. So when you write this instruction, the jump from one location to another location is possible only when the carry flag is set to 1. JNC stands for jump if carry flag is not set. JB, JNB, JB, jump if bit, B is bit. Jump if bit is high, JNB is jump if bit is not high. That means unless and until the given bit is 0, when you write JB, unless and until the bit is 1, the jump will not happen. And the reverse of that is JNB. Unless and until the bit is equal to 0, jump will not happen, right? Similar to that, you have JBC. If a bit is set and clear, then jump, right? Jump is if the bit is set and clear. It is checking the two conditions, that is JBC. So with this, we are completing various Boolean instructions of 8051, and let me summarize the fundamental behind Boolean operation. Boolean operation in 8051 fundamentally means that we want to perform single bit operation, right? So in 8051, you will have to consider that there are two levels of operations. One operates on byte, the other operates on bit. So whenever you want to operate on single bit, we have to make use of bit oriented instruction, that is Boolean instruction. Thank you so much.